Hi students, have a nice day. In this section we are going to discuss about the preparation of alkanes. In the last section we discussed about the alkanes, the structure, nomenclature, isomerism, etc. So preparation means the alkanes are prepared in the laboratory as well as in the industrial preparation. Industrial preparation is known as manufacturing. Okay, so preparations, small scale preparation is known as laboratory preparation. Large scale preparation is known as manufacturing of compounds. Okay, alkanes are prepared from, the first one is from unsaturated hydrocarbons. What are unsaturated hydrocarbons? The hydrocarbon which contains multiple bonds. That is double bond and triple bonds. So from alkene and from alkynes, alkanes are prepared. Okay, from alkene and from alkynes, alkanes are prepared. The method is hydrogenation of unsaturated compounds. What is hydrogenation? Hydrogenation means addition of hydrogen. Okay, please listen. Hydrogenation means addition of hydrogen. Hydration means addition of water. Halogenation or chlorination means addition of chlorine. Okay, are you clear? Yes. Okay, the first preparation from unsaturated hydrocarbons. Preparation 1 from unsaturated hydrocarbon. Unsaturated hydrocarbon. A. Hydrogenation. Okay, this is you studied in our class. Let's take a particular example. Ethene, CH2 double bond CH2. CH2 double bond CH2. 1 mole of hydrogen is added. Okay, 1 mole of hydrogen is added. In the presence of catalysts like nickel or platinum or palladium. Okay, what are the different catalysts used? Nickel, platinum or palladium. We get CH3, CH3. Okay, CH3, CH3. Are you clear? Yes. Here what happens? The pi bond is breaking. Also the hydrogen and hydrogen bond breaks. One hydrogen is added to this carbon, another hydrogen is added to this carbon. Okay. Actually what happens means, at the surface of catalyst, the reactor molecules are adsorbed and at the surface the reaction takes place. To understand easily, I explain one of the bond, that is pi bond is weaker. The pi bond breaks, the hydrogen bond breaks to the and breaks and add to the alkene, we get alkanes. Okay, then higher molecules CH3, CH double bond CH2. In the presence of hydrogen is added in the presence of nickel, platinum or palladium. Okay, this reaction can be written as like this, no problem. Hydrogen is a reactant, attacking reagent, and in the presence of nickel, platinum or palladium. Both way are correct. So what we get? The double bond breaks and a hydrogen is added. So we get CH3, CH2, CH3. So 1 mole of alkene, please listen, 1 mole of alkene required 1 mole of hydrogen. Okay, so 1 mole of alkene required 1 mole of hydrogen, we get 1 mole of alkanes. Okay, this is the one of the preparation of hydrocarbons, alkane. So this process is known as hydrogenation. Okay, so hydrogenation means hydrogen is added to the multiple bonds. Okay, hydrogenation. Okay, the next we take alkynes. Okay, alkynes. So this is one preparation from alkene. Next is alkyne. CH triple bond CH. Okay, CH triple bond CH plus H2 in the presence of these catalysts, palladium or platinum or nickel. What happened? 1 mole of hydrogen is added to 1 mole of alkyl. We get CH2 double bond CH2. Okay, 1 mole is added to alkyne. CH becomes CH2. This CH becomes CH2. One of the pi bond breaks. Remember that? One of the pi bond breaks. And again, if excess hydrogen is there, what happens? Hydrogen is again reacted with the presence of catalysts, palladium, platinum and nickel. What happens? Okay, CH2 plus H2, what we get? It is CH3. So alkene need 1 mole of hydrogen. Alkynes need 2 moles of hydrogen. Where the 2 moles? 1 mole of hydrogen is added, we get alkene. And again 1 mole of hydrogen is added, we get alkanes. The reaction is shortly written as CH triple bond CH plus 2 moles of hydrogen in the presence of nickel or palladium, we get CH3. Okay, this is also correct. Okay, this reaction is also correct. Are you clear? Yes. So, these two reactions are the method of preparation of alkanes from unsaturated hydrocarbon. Okay, unsaturated hydrocarbon. Are you clear? Okay. The next is from alkyl halides or haloalkanes. Alkyl halides or haloalkanes. Next preparation from the alkyl halides. From alkyl halides. Alkyl halides means an alkyl group a halogen. Okay, halogens are fluorine, chlorine, bromine, iodine. What are alkyl halides? Alkyl halides means one alkyl group. The halogen is attached to the alkyl group. It is called alkyl halide or haloalkanes. And the first method is alkyl halide is treated with a dilute hydrochloric acid in the presence of zinc, except fluorides. Okay, so except fluorides, alkyl halides treated with a zinc and a dilute HCl. Okay, zinc and dilute HCl. So let's take one example. CH3 Cl. Okay, CH3Cl. Methyl chloride. The alkyl group is methyl group. Halogen, you remember that. In this case, except fluorides, chlorides, bromides, iodides react with the zinc and dilute HCl. We get alkanes. So, in hydrochloric acid, we know that H plus is present. Okay, H plus is present. And in the presence of zinc, here zinc is the catalyst, we get methane. Okay, we get methane. And the byproducts are HCl. No need to write it. Okay, so here 2H plus, we can write that HCl. One more example. CH3, CH2, Br plus 2H plus in the presence of zinc. In the presence of zinc, remember that one hydrogen is added to carbon atom. Here also one hydrogen is added to CH3 group, it will become CH3, and the second hydrogen takes the hydrogen. Here also two hydrogen, one hydrogen is added to alkyl group, we get CH3, CH3. Okay, CH2, the CH2 becomes CH3 and the other hydrogen goes with the bromine atom HBr. Okay, HBr. Generally we can write that Rx, X is equal to Cl, Br and I plus H plus in the presence of zinc RH plus HX. RH means alkyl group and a hydrogen, it is alkane. This is general equation. These are particular examples. Okay, are you clear? So CH3 Cl plus H2. Okay, in the presence of the H2 comes from the acid. Okay, then next is a named reaction, Wood's reaction. Wood's reaction. From the alkyl halide, first reaction is treatment of HCl and zinc. And the second reaction is Wood's reaction. Wood's reaction. It's a named reaction. Okay, you remember that? It is a named reaction. Wood's reaction is alkyl halides is treated with the sodium in the presence of dry ether. Okay, alkyl halides are treated with the metallic sodium in the presence of dry ether. We get hydrocarbons, that is alkanes. And remember that here the medium should be dry. Otherwise, if the medium is moisture or any water content, the water react with the sodium and the reaction is going other way. So here very important thing is the reaction must be conducted in the inert medium. So that we are taking dry ether as an inert medium. Let's take one example, CH3Cl. Okay, 2 moles of CH3Cl plus sodium in the presence of 2 sodium in the presence of dry ether. Okay, in the presence of dry ether, we get CH3 plus 2 NaCl. Okay, CH3 plus 2 NaCl. So here the CH3 group is make a bond with the CH3 group. Okay, CH3 and the CH3 combines. Let's take another example. This is also from alkyl halides. Let's take another example. CH3, CH2, Cl or Br, 2 moles in the presence of sodium. The reaction can be written as like this, dry ether. Okay, in the presence of sodium and dry ether, we get CH3, CH2, CH2, CH3. So here, what is the alkyl group that is multiplied? Here CH3 is the alkyl group, it will become twice. That is CH3, CH3. Here ethyl group is taken, so we get butane. So number of carbon atom in the product is twice the number of carbon atom in the reagents. Okay, remember that? Number of carbon atom in the product, in the final product, is twice the number of carbon atom in the starting molecule or the carbon atom which is present in the alkyl group. And here is a conclusion. We cannot prepare methane. Methane can be prepared. We cannot prepare methane and the hydrocarbon alkanes with the odd number of carbon atom. This is the drawback of Wood's reaction. So what is the drawback of Wood's reaction? The drawback of Wood's reaction is we cannot prepare methane, CH4, and odd number of alkane. The alkane which contains odd number of carbon atom. Okay, so some students asking, sir, what about methyl group and ethyl group taken? Okay, methyl group and ethyl group. Somebody has doubt. Okay, I'll explain what happens. CH3Cl plus CH3 CH2Cl in the presence of sodium and dry ether. Usually the students think the two chlorine atoms taken by sodium and the methyl groups and ethyl group combine to form CH3, CH2, CH3. Okay, this is expected, but the problem is this is a mixture. So we cannot control the reaction mixture. Byproducts are formed. Okay, these two are combined to form propane, but the other possibility is CH3 combines with the CH3, ethane is formed. And the CH3, CH2, ethyl group combines to form CH3, CH2, CH2, CH3. We get mixture of alkanes. Okay, when we take different alkyl groups, the final products is a mixture of alkane and it's difficult to separate it. Okay, propane, ethane and butane. There is a difficulty to separate it. That's why we say that Wood's reaction is used to prepare alkanes with an even number of carbon atom. Methane and the alkane which contains odd number of carbon atom is difficult to prepare. Okay, so very important. Methane and the hydrocarbon or the alkanes contains odd number of carbon atom is difficult. Are you clear? So, can you follow me what happens in this reaction? Here, only one type of alkyl group, the final product which contains twice the number of carbon atom. So, we try to prepare an odd number of hydrocarbon by taking CH3Cl and CH2Cl. The products are, we get one alkane with an odd number of carbon atom, but the problem is the mixture which contains other hydrocarbons. So here propane, ethane and butane. So methane and hydrocarbon with odd number of carbon atom cannot be prepared by Wood's reaction. And another important thing, the reaction should be conducted in the dry medium, inert medium. Otherwise, any moisture, anything is present in the mixture, the sodium combines with the water, form sodium hydroxide and hydrogen. Okay, you know that what happens when sodium is react with the moisture or water. Okay, so to understand the reaction easily, we take one simple method. Okay, first of all we take this one. You take CH3, CH2Cl plus 2Na. You write 2Na. And the molecule is repeating 2 moles. So you write Cl, CH2, CH3. And the 2 chlorine atom is taken by 2 sodium. You can easily write the product. This is an easy way to write the product of Wood's reaction. Okay, this is an easy way to write the Wood's reaction, dry ether. First you write one molecule. Okay, somebody has doubt. This is correct. 2 moles of alkyl halide in the presence of sodium and dry ether, we get hydrocarbon, higher alkanes. But it is easy to understand. Any alkyl group comes, you have to write this. Okay, CH3, CH2, Cl, 2 moles of sodium. Another molecules you write in the reverse pattern. Okay, reverse pattern, Cl, CH2, CH3. And by taking the 2 chlorine atom, we get the alkyl group CH3, CH2. First you write that. And by joining the other alkyl group CH2, CH3. Okay, to understand this, one more example I explain. Another is isopropyl bromide. Okay, isopropyl bromide. CH, CH3, Br. Isopropyl bromide. You repeat the same molecule, Br. Before that you write sodium, Na, 2 sodium, plus Br and this molecule repeated in the reverse pattern, CH, CH3, CH3. In the presence of, there is no space, that's why I write here. In the presence of dry ether, dry medium. So what happens? You understand that Cl and Cl is taken by sodium. Similarly, Br and Br is taken by sodium atom. And first you write this species. CH3, CH, CH3. And write the other parts CH, CH3, CH3. Okay, a very simple method. And the final product should be correct. By using this pattern, this method, you have to write the product correctly. No need for confusion. What is the compound? 1, 2, 3, 4. It is 2, 3 dimethyl butane. Okay, 2, 3. In this direction, 1, 2, 3. In both directions, the position of substituent is 2 and 3. So 2, 3 dimethyl butane is the final product. Are you clear? Yes. Okay, it's a very important reaction. That's why I explain more examples. Wood's reaction in textbook, 1 or 2 examples and a conclusion. So you take more examples and practice it. Next from carboxylic acid. Okay, next method from the carboxylic acid. So remember that in Wood's reaction, methane cannot be synthesized and hydrocarbon with the odd number of carbon atom cannot be synthesized. Okay, then we move to the from carboxylic acid. The third reaction from carboxylic acid. What is carboxylic acid? The acid which contains the alkyl group or aryl group which attached to the COH. Okay, COH group is carboxylic acid. Here, carboxylic acid is heated with soda lime. Okay, carboxylic acid is heated with soda lime. What is soda lime? Sodium hydroxide and calcium oxide. Not a soda plus lime. Some students say soda lime is soda plus a lime. In chemistry, soda lime is calcium oxide and sodium hydroxide. The other is lime juice. Okay, it is if it is in the shop, it is lime juice, soda lime. Okay. So here the soda lime, you understand that soda lime means calcium oxide plus NaOH. This is soda lime. Calcium oxide plus NaOH. Okay. So RCOOH. RCOOH. Then here a soda lime is used to prepare alkanes. CaO plus NaOH. Heated. Okay, heated. We get RH. We get RH plus Na2CO3. The byproduct is Na2CO3. Okay, the byproduct is Na2CO3. Let's take one particular example. CH3COOH. CH3COOH, ethanoic acid or acetic acid. Acetic acid or ethanoic acid. Calcium oxide plus NaOH. What happens here? The COO group is removed and the hydrogen is added to the alkyl group. The same thing happens here. COO group is removed and the hydrogen is added. That's why we get CH4 plus Na2CO3. Okay, the byproduct is Na2CO3. Okay, and remember that in some textbook the reaction is given CH3COONA. Why? You know that this is acid, NaOH is base. When you mix the acid and the soda lime, first this base is reacted to gives its sodium salt. Again CaO plus NaOH, heated. Delta means heated. Okay, delta means heating. The COO group is removed. NaO is added to this group. We get Na2CO3. Okay, COO, NaO. We get Na2CO3. And the hydrogen is added to the alkyl group. We get CH4. This is usually written in some textbook. This is also correct. Okay, RCOH. Here one step we dropped. RCOH is heated with a soda lime. We get alkanes. And the COO group is removed. And that's why this reaction is called decarboxylation. Okay, decarboxylation method. Why it is called a decarboxylation? COO group, carboxyl group is removed. That's why it is called a decarboxylation reaction. So what we get are decarboxylate, we get hydrocarbon, we get alkanes. And I think you understand that, you understand one thing, we can prepare methane. Methane can be prepared by decarboxylation. Another one, CH3, CH2, COO minus Na plus. Or you can write CH3, CH2, COH like this. In the presence of soda lime, what we get? The group is removed. Decarboxylation. This group is removed and hydrogen is added to alkyl group. So Na2CO3. So decarboxylation method prepare methane, ethane, propane, any hydrocarbons. Any hydrocarbons prepared by decarboxylation method. In the Woods reaction, you remember that the hydrocarbon with the even number of carbon atom in the product. Methane and hydrocarbon with the odd number of carbon atom cannot be synthesized. That is Wood's reaction. Here we can prepare even number of hydrocarbon, odd number of hydrocarbon. That is a merit of decarboxylation reaction. One more reaction is Kolb's synthesis, Kolb's electrolysis. Okay, Kolb's electrolysis. From carboxylic acid itself, the second method is Kolb's electrolysis. Kolb's electrolysis. Okay. So first one decarboxylation, second one Kolb's electrolysis. Kolbe, Kolb. Okay. Some teachers pronounce it Kolbe. Kolb's electrolysis. What is electrolysis? Electricity is passing through the electrolyte. It decomposes, gives products. Okay. The electrolyte decomposes, gives product is called electrolysis. Okay. So when electricity is passing through the electrolyte, products are formed. That is called electrolysis. Here, a sodium or potassium salt of carboxylic acid is electrolyzed, especially potassium salt. Okay, sodium or potassium salt of carboxylic acid is electrolyzed. We get alkanes. Okay, let's take an example. CH3 COO minus K plus. It's an electrolyte. Okay, a strong electrolyte. Usually carboxylic acids are weak electrolyte. That's why we take sodium or potassium salt. Then electrolysis. Electrolysis. Electricity is passing through the solution or electrolyte. We get CH3 plus carbon dioxide plus H2 plus KOH. Okay. No need to bother about the byproducts. Usually in organic compounds byproducts are not written. Okay, byproducts are not written. But we try to study that. Okay. So when you take a sodium salt, CH3COO Na, okay, Na plus, you get CH3 plus CO2 plus NaOH. Okay, this is electrolysis of sodium or potassium salt of carboxylic acid. Then what is the drawback of this reaction? What is the drawback of this reaction? We cannot synthesize methane and the hydrocarbon with a odd number of carbon atom. Okay, we cannot synthesize methane or the hydrocarbon with a odd number of carbon atom. And the mechanism for this reaction. Okay, mechanism means what happens at the electrodes. You know that electrodes are the metal rods dipped in the electrolytes. So at an anode, oxidation takes place. You just understand the mechanism. At an anode, CH3 COO minus gives CH3 COO free radical plus 2 electron. Oxidation. Oxidation is the removal of electron. And that CH3 COO free radical gives CH3 free radical plus CO2 gas. And this You know that alkyl free radicals are highly reactive, unstable, that's why highly reactive. So CH3 free radical plus CH3 free radical, we get ethane. So what is the alkyl group which attached to the carboxyl group? The alkyl group is twice in the product. Okay, this is mechanism. First of all, CH3CO minus during electrolysis. The reaction takes place at anode. At anode, oxidation takes place. Okay, so oxidation means the removal of electron. So here you take 2 moles. You take 2 moles, that's why you get 2 electron. Here also 2, you take, so 2 moles. Then here 1 plus 1, 2, we get CH3. This is the reaction. Okay, so CH3 and CH3 gives CH3. And in the cathode, at the cathode, reduction takes place. What is reduction? Gaining of electrons. So H2O plus electron. You consider 2 electrons. So you take 2 H2O plus 2 electron gives H2 gas plus 2 OH minus. H2 gas plus 2 OH minus. This OH is combines with the K plus. We get KOH. So which gas is liberated at anode? Alkanes. Alkanes liberated at anode. Hydrogen is liberated at cathode. Okay, so that's about the preparation of alkanes. A very important section. You go through it. Any doubt you can ask it. So this is the different methods to prepare the alkanes. And the next section we will discuss the properties of alkane, physical and chemical properties. Thank you.